Have you ever wondered why you shouldn't eat raw cookie dough? Well, the answer lies in this bacteria right here, Salmonella typhimurium. Salmonella causes food poisoning in over 1.35 million Americans every year. Salmonella is typically contracted through the consumption of undercooked poultry and raw eggs, hence why you shouldn't eat that cookie dough. Salmonella is easily contracted because of its unique ability to survive in multiple types of environments, such as inside the GI tracts of chickens, inside eggs, and even on surfaces for several days because of its ability to form a biofilm. Because of this, farmers have resorted to the use of harsh chemicals such as bleach and formaldehyde to kill off salmonella at the source before it hits your dinner table. But this can be problematic because not only does it harm the chickens, it doesn't even address the bacteria living inside them. That's where my research comes in. I aim to develop a disinfectant made out of nutrient-type compounds that can effectively inhibit salmonella growth both on surfaces and maybe even in feed additives. A nutrient compound is a chemical that naturally occurs in the environment and is non-toxic to humans and animals, yet might still be effective at inhibiting bacterial growth. As you can see here, prior research has found 10 different nutrient compounds that inhibited salmonella growth. One of these you might recognize is salicylic acid, which is a common ingredient in acne medication. So the first step in my research, since most of these are acids, is to figure out if they are effective via their pH. We can put these chemicals in a buffer solution to neutralize that pH and test them to see if they're still effective. We found that salicylic acid is effective regardless of its pH. The next step is to determine the inhibition kinetics of each chemical, basically just figuring out what application methods are the most effective. We can put the chemical down first as a prevention method or after bacteria as a treatment. The next step is to figure out what types of organisms these chemicals are effective against. We can test them on a variety of agriculturally relevant bacteria, such as E. coli, and maybe expand this product to other agricultural facilities. While this research is happening, another lab will conduct a variety of gene sequencing techniques to figure out what genes are activated or inactivated in salmonella when the chemicals are applied. Using this information, we can genetically modify salmonella and create mutants to figure out exactly what's happening on a cellular level. So, based on all of this information, we can choose several chemicals that seem to work effectively by different methods, combine them, and test them in a chick infection assay, and figure out if they can inhibit salmonella growth. So, by the end of my research, you might just be able to eat that raw cookie dough. Thank you.